perfect. Well, thank you, Troy. Like you said, I'm Mike Malasaw. I've been with Monson now for 2 years. Really kind of made these 3D products, a goal of mine to make them successful for us and for our customers as well. So I've taken a lot of pride in working with the X7. I'm going to do maybe a 5-minute PowerPoint. I really just want to get some notes up that we can come back to and reference in the video recording that we're going to have. So this is recorded. You will be able to go back and check out some of these specs that I'm going to put on the screen here in just a second. So we're going to introduce the X7, and then I will move into perspective and try and cover pretty much every tab there is in perspective and really break it down for you guys. Okay, so why the X7? The 3 reasons really is that it's simple, smart, and professional. And like I said, I'm not going to read these word for word, but I will break these down a little bit. So the X7 compared to other scanners is definitely very simple and intuitive to use. I've seen a lot of customers that are first-time scanners that get out and are pretty successful with the X7. So it's very easy to use, and you'll see that through the demonstration here in just a few minutes. No. So second point is that it's a very smart scanner. So with the X7, we have the ability to auto-register from scan to scan, or even go back to a previous scan and register to that. Never really have seen the ability to do that. And then even if things don't register, we have the ability on the tablet in real time to do those in-field registrations. So you can leave the job site with a fully geo-referenced, fully registered scan, ready to really start working on your deliverables in the shop. So there's a lot less work to do in the office that we can finish in the field. Lastly, it's a very professional piece of equipment. I believe it's IP55 rated, so it is pretty rugged. It'll take to the elements pretty well, and I believe there's a slide that has actual specs on that next. Okay, so this page is really more for everybody to be able to revert back to and get a technical overview. I'll leave it up for just a minute. Like I said, the IP55 rating, the temperature range is anywhere from -4 to 122. Another big point to take away from this page is our measurement range. So we can scan anywhere from 0.6 meters up to 80 meters away, and that is a full dome scan. This isn't set up like the SX12, where we can do a horizontal band scan or just a polygon. This is going to do a full 360 dome scan. The only thing that it's not going to capture is the area right below it. So our field of view is 360 by 282. And a lot of this stuff is going to be covered in the demonstration. So like I said, I'm not going to go word for word. Okay, what's included with your X7? So we are going to have, of course, the X7 scanner itself. You also have to have something to load your perspective software on. The one I'm using today, I actually have perspective on my laptop, but we have other tablets such as the T10 or T100 that you can load the perspective software on. You can also load that onto any spec'd out Windows 10 device, so Surface Pro, anything like that. You would have the ability to put perspective on it as long as it met minimum specs. It also comes with a Gitso tripod, very lightweight carbon fiber tripod, makes it really easy to transport, and 2 carrying cases. So you'll see in the picture here, we have the backpack carrying case, which is the one that we use most of the time, but it also comes with a Pelican case to travel with and keep your scanner a little more safe, a little more of a rugged option. Okay, and also battery-wise. So if you're already using Trimble total stations, these batteries are the same as your S-Series robots or SX series scanning robots. So very, very versatile batteries that goes into a lot of our equipment. Okay, so the big selling point for this X7 would be the registration assist and automated registration that the scanner is capable of, or at least Perspective is capable of. Throughout the demo, I'm actually going to do a couple of like 2.5-minute scans and just show it in real time. And then I'm going to import a data set that's been fully registered and georeferenced as well for us to take a look at. Benefits to having all this field work done is cut down on site revisits, and you're able to capture everything in one go and make sure that you're leaving the field confident that you can bring it into TBC and put it straight to a deliverable. Okay, here's another slide that's really going to be a good reference page. I'm not going to read off everything, but this will talk about your point spacing, your number of points based on the duration of scan, as well as file size. So I'll leave this up here just a minute and allow you guys to reference back when rewatching these videos. Okay, so there are 3 onboard coaxial 10 megapixel cameras. Really great image quality. There's 2 different settings that we're going to go over in the demo, but you have the ability to do a faster image capture with only 15 images. This only takes a minute of time, but if you did need a higher quality image, you do have the ability to take 30 pictures in a matter of 2 minutes and really get the finer details of your scan. So if you're looking for labeling on piping or bolt patterns or anything very small and finite, that would be the way to go. All right, and when we get into the demo, we'll talk about our scanner presets. So you have the ability to basically set your scanner up for your environment. So depending on the lighting, if you're outdoor, if it's cloudy, if you're indoor and you're in incandescent lighting, we'll have the ability to adjust our scanner and account for those different conditions that we'll be scanning in. Okay, here's just a brief look at some of the top applications that are using the scanner successfully. I'm sure that list could go on and on, but here's just 10 for you guys to take a look at. And I believe most of our customers are going to be building construction, topographic surveys, utilities, and things like that. Okay, so without further ado, I'll go ahead and get into perspective. Is that coming through okay as well? Yeah. Okay. Okay, so before we get started actually scanning, we're going to go over some of the settings in Trimble Perspective and how to check out the quality of your connection to your scanner, as well as do a field calibration, do a diagnostic of your scanner. I'll show you how to get to those points. So top left of the screen, I'm just going to tap on the menu button and check out settings. Okay, so under our general tab, we have the ability to change a few things. We can switch the way our mouse works and works with our data to a reverse mouse zoom, almost like an Esri or GIS type scan situation. We have the ability to turn off application sounds if need be, if you're in a situation. This next button here, unlock station leveling during refine, is a pretty powerful tool as well. What this does is it allows you to unlock the leveling of your scans during your registration refinement. It improves the results of your registration for accounting for smaller variations in leveling of your scanner. The only time I would recommend not doing this is on a long, straight, linear survey. So that's when this would cause issues. But if you're looking for more finite details and you're in a smaller space, this is a pretty powerful tool as well. Last couple things, we could change the language if you need to, as well as the number of scans that are displayed in our filter. Okay, so when you get your X7 scanner, it's going to default to metric. These are produced in Germany. So what we do is just come in here just like our Trimble Access on our TAC7s and change our units to US survey feet. So it's a little more native to what we're doing. Everything else should look pretty familiar. Our coordinate display is going to be northing easting elevation when we do import control files for georeferencing as well. So I mentioned in the brief PowerPoint that we could define the number of images that we're using basically for higher quality imagery, or if we just wanted a faster scan. So this is where this is done. Once again, it defaults to the 15 pictures, but you can turn that up if you're looking for higher detail and you're looking for words on piping and smaller things like that. And here we also have the ability to turn on our automatic panorama creation. So I'm actually going to leave it off for time's sake today. So when we do our export, I'll show you where you can also add the panoramic pictures to the option. This last tab is our scanner tab. So this is going to tell us a lot about the scanner that we're connected to. And generally what you would see is a Wi-Fi connection and the quality of that Wi-Fi connection here. For the purpose of what we're doing today, I'm actually cabled into it and I've turned off the Wi-Fi capability. So if you see it, we're going to be connected via USB. We also have our battery life, our remaining battery life on the scanner. So that should get us through the roughly 45 minutes to an hour of perspective that we're going to look at. In this next tab, each X7 has an onboard SD card that serves as somewhat of a backup for your data that's stored locally on your tablet. So anytime you're connected and scan, all that raw information will be stored on the SD card. So here all we're doing is just checking the amount of storage we have left, but we can erase scans, check our disk, and format a new SD card if we need to. The last tab over here is the report tab. So this gives us the ability to run a diagnostic and field calibration. And just for numbers purposes, I ran the diagnostic and field calibration last night, and they both take anywhere from 3 to 5 minutes. And I've got copies of those reports here. Let me know if these come through, Troy. Yes. Okay. So this is our diagnostic report. And once again, I'm not going to go word for word, but it does give you information about versions of firmware that you're using, making sure everything's compatible. Like I said, I disabled the Wi-Fi on this, so we get a big fail there as first thing, but it's actually okay since we're cabled in. But everything else you can check out the health of your main board, your cameras, deflection units, so on and so forth. So this is just a pretty powerful tool. If you needed to possibly send this off, you can at least have a check for yourself and understand what's going wrong with your scanner before it goes out. So I'll just scroll through these real quick. I'll try not to bore you too much. Okay. So our scanner is in good health. Like I said, the only thing that ran wrong was our Wi-Fi connection. Next, we have a field calibration report. And once again, this took anywhere from 3 to 5 minutes. We had a successful calibration check as well. But we'll go through the details and just shows the information that you guys are, or that they'll be looking for if they were to have to service this X7. Bless you. Okay. You guys see perspective again? Perfect. Okay. So back into perspective, I think that's really the meat of what you're going to look for in this menu section. There is a help button that will take us to a web page basically showing, an overview of the equipment, and then you'll have different notes on how to refine a georeference, how to organize, create points, measure. So this is just a really good how-to guide if this is something new for you, if you've never used this before. Last tab in here is just our About tab. It's going to show our versions of firmware that we're running. So if you ever do need to update it, this is where you could check for it. Okay, without further ado, I'm just going to start by creating a new project. We are going to end up importing this Yankee Street project over here to the left and check out geo-referencing, and then we'll do some manual registration just to show you the workflow in that as well. Okay, so we'll call this project hashtag 3D workshop. Okay, and then we do have the ability to take a photo. It's going to probably take a picture of me, so I'm going to not do that. I'm not feeling too pretty today. You can also throw a brief project description, just something good to tell your scans apart if you're scanning similar things over and over again. So if you're in mech rooms, you could possibly put a room number in here, or just some good notes to differentiate. So I'll just throw test in there and create our project. Okay, just to start, a lot of that information we saw on our settings page is going to be here at the top ribbon of the page. You click on here, it's going to show you the quality of your Wi-Fi connection along with your battery life and SD card storage. But we've already been through all of that. So we'll move along. Okay, in our menu button, we have the ability to, I'll just go through line by line. This top one, we would just go back to all of our previous projects that have been created. Any project that is created is automatically saved. So let's say we start a scan in here, complete our scan, go back out and open another project. We don't have to do anything extra to save that scan. All that data will be saved locally to the tablet that you're using along with on the SD card as well. Another really cool tool that's new in this latest version of firmware, I believe, is synchronized scans. What synchronized scans does is it allows you to scan without being connected to a tablet or a computer. So the X7 itself does have a one push button capability to where you press the button and it will scan with all of the previous settings that it was using on a prior scan. Once you are reconnected to a tablet, you can synchronize these scans and import them into Perspective and be able to view that data. So pretty cool tool, and I believe it's new. So this is something that I haven't been able to put to use, but do understand the importance of it if you don't happen to have that tablet in the field. Okay, next we can import a previously scanned job in Perspective. So the two file formats that you can import are Trimble natives. They're going to be a Trimble TZF or a Trimble TDX file. Like I said, we're going to be working with this Yankee Street Stadium, so we ended up importing this one prior to this webinar. We're going to go through refining our registration, geo-referencing our project, as well as displaying our refine report showing our overlap between our scans. There's a lot of good information we'll see from this refine report, but that will come up after we do 2 or 3 scans in here. Okay, on to the bottom of the screen. This is kind of where the meat happens with Perspective. It's really what you can do to alter your scans, get higher quality amounts of points. A lot of good information here. So for today's purposes, we're just going to be doing 2-minute scans. This scanner does have the ability to go 2, 4, 7, or 15 minutes. One thing you will notice when we do a 2-minute scan is we don't have the ability to do a high sensitivity scan. So when we switch that to 4 minutes, we can do a high sensitivity scan. And I want you to note the number of points. So we're doing a standard 4-minute scan. We get 58 million points with 200 spacing. If we are to change that to a high sensitivity mode, it does drop our number of points and our spacing just a little bit. But what that high sensitivity mode is allowing you to do is scan in darker areas or more reflective surfaces. It's slowing your scanner down, and if anybody from Trimble wants to step in and correct verbiage, that would be great. But really, the way I understand it is it's going to slow your scanner down and allow it to focus on these dark surfaces and get more quality points rather than a mass quantity of points. So high sensitivity mode really does help this stand out in dark and reflective surfaces better than other scanners have in the past. Okay, we'll switch that back to 2 minutes for our actual scan we're going to do here in a minute. So we have the ability to turn images on as well as high definition resolution images. For the purpose of time, I'm not going to turn on HDR today, but it is something that we have the ability to do. And lastly, before we start scanning, we do have, I was talking in the PowerPoint about the lighting conditions that we can set before we start to scan. Generally, I default to the auto white balance, but if you are in a situation where you think you really need to focus on your surroundings, we do have the option to scan in cloudy conditions, sunny conditions, fluorescent or incandescent lighting. Once again, I'll leave it on auto for today. Okay, for the scanner itself, it is self-leveling. So up to a 10-degree offset, you will still be able to self-level. And each time we do perform a scan, it goes through like a 25 to 30-second calibration before it begins collecting points. I'm going to go ahead and just start a scan. Can they see that? Yeah. Okay, perfect. Okay, so I did a poor job of leveling on purpose. Right now it's going through calibration and leveling, allowing us to be able to scan. Very simple to use and maneuver. So once we're done with the scan, I'm literally going to pick it up on the tripod, move it to the next position, not deal with leveling at all, and we'll be ready to do our second scan. Okay, so while that's scanning, we'll just do a quick rundown of these tabs over here on the left side of the screen. And then by the time we're done with those, we should be able to view some data, do some measurements, and import some control points. Control points for today. I don't have actual control in this room. And as you can see, we can see down at the bottom progress of our scan. So on the right side of our screen, we have all of our stations. So each setup is going to have its own station. And we're going to have notes in here, such as our application of geo-referencing. It'll let us know if it's successful. It'll show us the success of our registration as well. Once we have some scan data, we'll be able to create annotation points and precision points for geo-referencing. We'll go through that workflow. That's that second tab down here below. Third tab we have is a measurement tool. So in here, we'll be able to do a 2-point measurement. We'll also be able to do a horizontal and vertical measurement, and we will go through that as well. And then lastly is just a notification bar. So anytime something's going on with our data or our scanner, we will get notifications down here at the last tab. Okay, I'm going to pick it up and move it after we capture images. So that's another thing. We want to make sure images finish capturing before we move it. But while those are being captured, we do have the ability to manipulate, rotate, and view our data. One thing we'll be able to do when we have multiple scans registered together is use this magnifying glass and really hone in on a single point and check the quality of our overlap and registration and make sure there's not a whole lot of noise and we don't have to do any manual moving to the data itself. Okay, so I am set up for my second scan. We will do a couple things before I start it, but we will be able to continue to move. Now that we have data, we will be able to continue to manipulate data, while the second scan is going on. Okay, so this is a secondary view. Down here at the bottom left, we have an ability to toggle between our views and really focus on a single point cloud compared to all of our points that we've scanned in a single project. So this right here gives us the ability to focus only on scan number 1. I'm going to go ahead and start scan number 2, and we'll go through some of these tools over here on the right side of the page. So we'll just work our way from the top to the bottom. What we'll do first is create an annotation point and a precision point. And then once the second scan is done, we'll go through what the geo-referencing workflow could look like, and then we'll also check the quality of our registration. So for our first point, I will create an annotation just to label the TV. I'll actually call it point number 1000 and then give it a description of TV. Why it's not letting me take pictures.
Because your video is on.
Possibly.
Using.
Okay, so as this is finishing up, this will allow us to create a point here in just a minute once scanning is complete. So while it's capturing those images, we can take a look at our registration from station 1 to station 2. So what we are going to do is check out our overlap between the two scans. So we have the ability to adjust this magnifier size and do a smaller portion if there's really an area you want to focus on and tie in between the two. But as you can see, this is pretty tight overlap between the two. We have green and blue coming out on both sides. So it looks like our registration is good. Well, but we will have probably 85 to 90% overlap because I'm scanning so close to each other. So we'll see that in our refining registration report. Okay. Just go through this one more time. Okay, so I tapped on the TV and we will just create our annotation point here. If we did have a photo and a description, we could click on this here and it would give us the details of our annotation point that we've created. But since we did not, there's really no details for us to take a look at. We're going to go through this once again for geo-referencing too. Okay. So now back into our single scan view. If you look at the top of the screen, we have the ability to toggle between our different scans. So you'll see the point of view is really going to be the only thing that changes. Beautiful scan of us working in here today. And we also have the ability to change the way that these point clouds are displayed. Defaults to grayscaled intensity, but we can look at it in color-coded intensity and really see the areas that were measured that receive more points than others, as well as we can take a look at unmeasured points, and it will struggle on darker and reflective surfaces. So this is just a good idea of the stuff you're going to struggle to pick up without the high sensitivity mode. Okay. So next, what I'm going to do is just create a precision point. We have the ability of turning on a laser similar to the SX12 demonstration that we did this morning. And what that laser allows you to do is really hone in on your control points, or it'll stand out on a black and white target really well and make sure that you're centered on these control points that you are georeferencing to. For the sake of what we're doing, we'll just call this 5,000 for the description of control point. And you'll notice what's different about the precision point and the annotation point is that this is actually going to scan it almost like using a total station. If we were using targets, we could count for our target height here on the right side of our screen. But since I'm just going to be scanning the ground, I'm going to go ahead and just do this at a 0 target height. Just a few more seconds and this will be done. There we go, and create our point. So now we have two different types of points. We have an annotation point, which will export with our data with good notes on whatever we're trying to annotate and differentiate between other points. And then we have a precision point that we could use for georeferencing. Now in a normal georeferencing workflow, we would want anywhere from 3 or 4, preferably 4 control points to georeference to. And there's a couple different ways that we can create or import our control points to connect to these reference points. So we're going to go back into our menu toolbar, and actually, there's a couple ways you could go about this. You could do the refining of your registration before you start your georeferencing, or you could go into georeferencing and do your refine through this. I'm actually going to do the first. Get out of there. And I'm going to refine our registration and just show the refining registration report once it's done. Okay. So anytime you refine a registration, it does create a registration report that can be saved with your job. So if customers are looking for your percentage of overlap or your average error between stations, this is where all this information will be. Like I said, I'm scanning very close to my first point, so I had no problem registering the two scans to each other, and we had very, very little error. So it's a good sign there. Okay, and then we've got a little bit of details of our distance between setups and our consistency and overlap information. So we have all that in our registration report, and you could save this and like I said, deliver it with your other deliverables. We're going to close out for now and look into the georeferencing tab. So here we don't have control points entered. So that precision point didn't come with any geospatial values, if you will. So what we have a couple of methods that we can use to generate these control points. So we can create, similar to how Troy did it in Access this morning. So what I would do is I would match the name of the scan to allow it to match from control point to our precision point. 5,000, pasting 1,000, of 1,000. Okay, so we have created a single control point. Like I said, for a normal georeferencing workflow, we would want 3 or 4. The example we're going to take a look at here in just a little bit has 4 control points in there. But while we're in the georeferencing tab, we'll at least look at what that will look like. So as you can see, we have our 2 points that are named the same, 5,000 and 5,000. I created that precision point to match what I was creating out of that georeferencing tab. So once we have a match, we can apply our georeferencing. Go ahead and hit it. Okay, so our project has been moved to that single control point. The only issue with the way I've done it is the fact that I don't have the others to account for tilt and direction and certain things like that. But really, this was more for understanding of how to get to that point. Okay, let's close out of the georeferencing tab. And we're going to take a look at our measurement tools that we have. Okay, so we do have the ability to do a single point, and where this would be useful is if we already have georeference data with actual coordinates. We also have the ability to do a point-to-point measurement in any direction. And it will tell us our distance from point A to point B. If you're looking for quick measurements such as width of a door or, I don't know, in our case, width of a whiteboard, it's a pretty powerful tool, and it's something to give you quick answers in the field if people are asking questions. Delete that one. Then we have the ability also to do a horizontal distance. So if I click anywhere over here on this door, it will level that up for us and give us a horizontal distance and tell us that our door is almost 3 feet. I'm assuming it's 3 feet, but with it open and me not focusing in on those points, it's a little bit less than 3 feet. Lastly, we have a vertical measurement. We'll just pick something random on the wall here just to show the tool. So there you have it. We have our 4 measurement tools. We have a single point, a point-to-point, horizontal, and a vertical measurement tool. So all pretty powerful for in-field deliverables. Okay. One thing I did realize is that I did not go through the import function on georeferencing. So very similar to other software such as TBC or Access, we can import a CSV northern easting elevation file. So here it would just be looking, let me try to find our control points. And then this is the format that you would import these and actually match our precision points to. So this is an example of a list of control points that we used on another project. But as you can see, it's very native to what we do and other aspects of using Trimble hardware and software. For now, I'm going to discard that and close out of the georeferencing toolbar. And I'm gonna unregister the 2 scans. So what we're gonna do is show you what it would look like on a tablet in the field if something was not to register, how you get to a registered data set before returning back to the office. Okay, so as you can see, we have this register tool here in the middle. I'm just going to break the link between the two. And so at this point, if you have multiple scans in your data set, you could try a different link. So if scan 2, or let's say scan 20 won't register to scan 19, you can look through here for a different scan. So say scan 18 or 17 might have more overlap or visibility. You can create that link with a different scan and try and register here with this tool here. For now, since we only have the 2 scans, what I'm going to do is create a split view between the 2 scans. So on the left, we have scan number 2. On the right, we have, on the right, we have scan number 1. So in a small area such as this, it's pretty easy to pick common points, but the workflow is really what I wanted to get across and just show that if something doesn't register, it's not impossible to get to that point. So what I'm going to do is select common point there, common point at the top of the door, and register scan 1 to scan 2 again. So I broke the registration and then I manually re-registered the 2 of them. Perfect. So pretty simple to get to that point if something's having trouble registering, if there's not a lot of vertical surfaces in the field. You'll be able to use things such as a curb or a stop sign or base of a tree, as long as they're both, if they're in both scans and they're able to see it. And we'll close out of our registration. The last thing, or one of the last things I want to look at in this data set, since it's so simple, is that we do have the ability before we scan to set our parameters for which scan we're going to register to. So let's say we're in a situation where we do 5 scans and we get to scan number 6 and realize that we missed some information previously. We can backtrack and get to a point and re-register back to either 1 or 2, and it has the ability to find those like points and stitch to a scan that was done previously. So if I was to move our scanner to this side of the room, it has a better chance of registering to scan number 1 than scan number 2. So I turned off the default of registering to our last scan and just switch that up. I helped the scanner basically know where it was at, essentially. Okay, just to briefly go over these tools over here. We've already been looking at this one, but we have the ability to rotate our scan and take a look at the quality of our scan in the field. We also have the ability to isolate an area and check the quality of our registration and make sure everything's tight enough for producing deliverables or doing any type of modeling in a downstream software. We have, let me get off of this. We have basically a zoom extents if you're a CAD guy. So this button here is going to be a zoom extents and get you, let me turn this off. There we go. Get you to the whole view of your scan. Now we have captured stuff outside of this conference room, so you're going to see a lot of sparse data out here to the top of this. Okay, we can also change our view very simply by clicking, our different side views, top view. So very simple tools there. Okay, and we also have the ability to turn certain things off with that tool there. Okay, so we've seen refining our registration, we've geo-referenced, we've seen a refined report. We'll talk pretty quickly about export options and different formats that you can export to. Once again, you see this pop up multiple times to refine your registration. Since we've already done it, we wouldn't have to refine our registration again. But I mentioned earlier that I don't default and turn on panoramas. I do it, job to job. So we have the ability here in our export function to create a high quality panorama. You can also colorize your point clouds through the export. I was talking with Pete, one of the product managers, the other day, and he did let me know that once these are colorized and exported, that those will stay colorized. There's no backtracking to just the raw point cloud. And if I'm saying that wrong, please, Pete, step in and let me know. Okay, so then we are going to talk about export formats, because that's the one thing that, or one of the things that sets this scanner apart, is that we don't necessarily have to go Trimble native. While it is faster and more user-friendly to go to a TDX or TZF, we do have the ability to go directly to RCP files, which are native to Recap. And a lot of users are already familiar with using Recap. I do recommend, if you're going to Recap, to export to this gridded E57 format. It tends to work a little bit faster, and then you're also able to choose single scans at a time to work on rather than one large RCP file. So going to, say you have 15 scans, you're going to have 15 individual E57 exports. And if imported all at the same time, they will maintain their registration, but you don't have to necessarily. You can just import a few at a time and work on certain areas of your scan. We also have PTX, POD, and LAS files. The one I'm most familiar with is the LAS file, as it's pretty compatible across the board for not only Trimble software, but your CAD softwares and other downstream software that you may be using. Okay. So I'm not actually going to go through the export. It would be, I don't know, a minute of time, but I don't really think it's worth it. At least we can see the process of doing so. So last thing I'm going to leave you with, I'm going to show you an imported project that has been fully geo-referenced and registered, and I believe Dan is going to be using this as an example in Trimble Business Center. Okay, so this application is probably going to be more familiar to what you guys as our customers are going to be collecting rather than a conference room. So I felt like it was pretty necessary to show what it can pick up on a road survey to look for things like curb and gutter, and you're going to see road signs and different things like that. So I'll start by taking a look at the individual scans. And show you just the quality of data that you're going to be picking up. Such things as road striping. If we zoom in over here, we're going to take a look at the quality of that curb there. It's just going to make it so much easier to extract in our downstream software in TBC. So we really see a high quality point cloud there. Top of our screen, I'm just going to toggle down to the beginning of where we started, because we have a good look at a lot of different annotations and control points that were created for this job. So as I mentioned earlier, if you have pictures and details, if you click on these, you can view your details of the annotations that were created. So as you can see on the right-hand side of the screen, we have a picture of this brass tag and a description, basically. So if we revisit this site, or if we're looking at it in our downstream software like TBC, we have the ability to label it. So the points that were used for geo-referencing, a lot of good information here, but it does show us certain things like our visible error in the geo-referencing workflow. So we were within a centimeter essentially when georeferencing this. So you get that type of information in the details once georeferencing is done, as well as certain things like our target height. So what he did was he scanned to black and white targets instead of 5-foot target height. Okay. Really, last thing I want to leave you guys with is just an image of the type of quality that you're going to collect with this X7. There's a lot of deliverables that can be created. The range is a little bit shorter, but the workflow makes up for a lot of the office time spent registering scans, having it registered in the field. I mean, we're able to see, you know, our striping, our curb and gutter, our trees, our poles, and take that to a downstream software and easily create a deliverable.
Mikey?
Yep.
So in this particular example, they created control with those black and white targets using some other instrument before they introduced the X7 and then did the georeferencing with the X7. Is that what you think happened?
Correct. So the question is were these control points created using another piece of equipment before going out with the X7? I believe this was done with an S-Series robot S7. They went out and they laid their 5 targets or 5 control points. And once they started scanning, they were able to tie back into that control. So that was done with a Trimble S7.
So he looks like he was using black and white targets on rods.
Yes.
So I'm sorry, I might have missed this, but specifying the target height, you georeference those black and white targets.
Yep. So
Or were those, because the black and white target was on the rod that was measured. So I'm just, why did you specify that you were georeferencing the target, not the?
So he was georeferencing the point. So he was georeferencing the point on the ground and used the black and white target for a target height. But since it's a good perpendicular view of his scan, it's a lot easier to see that black and white target than the monument on the ground.
No, but you georeference in perspective to the black and white.
Hey, Troy, this is Dan.
Yeah, Dan, I hear you.
All right. So what would you like to have clarified here?
Turn off your speaker though.
Okay.
So Dan, I'm just curious.
You said the control with an S-Series robot.
And then
when
you went through the X7 scanning a black and white target that's on a rod over those points, right?
Oh, yeah, Mike, go to station 1, please. And then just zoom in a little bit on the target. Okay, so there we have it. So now what's your question, Troy?
Well, he georeferenced in perspective to the black and white target, right?
Okay, so if you look at, so right now we're looking at the precision point. So use the laser. So in perspective, we dialed in on that center of that target, measured it, and then we've created the precision point. So we shot with the X7, center of the target. Now, if you look at the details over here on the precision point, we enable it as georeferencing. Precision point is measured to the center of the target. And this target it's a Trimble target as well. It has the same offset as the R10 prism, the Trimble 360. So it's a 0.135 millimeter offset. So we can use the telescoping rod with the S-Series instrument. And so we set that at 5 feet. And then in perspective software, it took the right there, it added -5 feet, which brings us down to where it says 5,000 black and white. So that's the label I use, is point number followed by identifying it. I shot a black and white target. So it minus 5 feet and places it down on the mark, and now it's matching. So and now it's matching the geo-reference coordinate. So we have our geo-referenced import values, and then we have the value shot from the X7 on the target with a target height applied.
Right. Okay, cool. I see the target height application right there. That makes perfect sense now. So just didn't realize that you had that capability.
And these
So
points,
if
these
you were
points were established with an SX12.
So if you were geo-referencing, you know, whatever, you know, the sides of a building or something, obviously the target height in those cases would be.
It would be 0, yes.
Okay, makes sense.